Okay, finally, part C. So, according to this one, Serena can identify in advance the samples that Yuto can analyze in under 50 minutes, and in future she'll assign these to someone else. Okay, so one thing to be very careful here, she's talking about someone else. In other words, this statement does not apply to Yuto. Okay? That's the thing. In the future, she'll assign these to someone else. So this following statement does not apply. So C, estimate the median time taken by Yuto to analyze samples in the future. If we go back to the previous problem in B, the statement earlier, it states here that she selects at random one of the samples that took Yuto longer than 50 minutes to analyze. We are still referring to Yuto, and even in the previous one, Serena is investigating the samples that took Yuto longer than 50 minutes to analyze. This statement here is just about somebody else, so be very careful not to use the less than 15. Okay, that's just be very careful. It's kind of sad because this is a very tricky trip-up question. So what do they want us to do? Now, to find the median time, let's have a look. So it's telling us specifically, and it doesn't matter which order, because the median is the 50th percentile, right? The probability I took, the time to be either less than or greater than 15. So I'll just say less than, because that's what they usually use. Then let's say the median time. Given that the time we know that Serena wants to investigate Yuto is always going to be greater than 15 minutes. That's how we begin, okay? So this would be the conditional probability. Now, let me just make this m look a bit more clear. Let's use a little m actually. Okay. Now, in this case, what does this mean? So let's go ahead and expand this probability, yeah? So firstly, we know it's going to be a given that, so it'll be probability t less than 15. Now, how about the top line? This tells us that the variable t lies between, which t is firstly bigger than 15 and less than m. So this, we can intersect these two. So putting t in the middle, it'll be between 15 and m, because it's bigger than 15 but less than m. So it's between them two, and that's the probability. Okay, and before I continue this one, just remember, both of these firstly equal 50%, so it equals a 50% mark for both of them. Now, we can actually tie this up really nicely. The bottom probability, we can actually resolve it. So probability t is greater than 15, well, we can multiply across, because we know the value of this one is 0.7257. So this would mean, so moving here, we now have the probability that 15 is less than t less than m is equal to 50% times 0.7257. So put that in a calculator and you should get, so I got about 36285. Okay, not bad so far. And now at this stage, we can convert this one to the Z form. So let's try it here, yeah? So it'd be probability that we got 15 minus the mean over standard deviation is less than the Z. And then m minus 18 over 5 equals the same probability, 36285. Now, we can quickly evaluate this one. So the cool thing, this one, we can just subtract the differences. So wherever the function of this one in the table, we can write this one as the the O should be there, of m minus 18 over 5 equals the IO of this value here, which would be 15 take away 18. So I think we already did this one, isn't it? 15 minus 18 over 5, of course we did, minus 0.6 must equal this probability. So the reason why this will help, because eventually we can make this a subject and we can solve this directly. Now this is the same as 1 minus this, so we're going to have the same term here, m minus 18 over 5 minus, and then maybe I should be very careful, 1 minus this one, IO 0.6. And just what did this one give before? Just always good to double check. Open up the distribution table. 0.6. Well, of course, it gave 7.257. What else can it give? So 7.257. Let me just get back to where I was. How was my 7.257? So it'll be 1 minus 7257. This will give us exactly 0.2743. Now you can add it to the other side, so then you can make this the subject. So add this across to the other side, plus 36285. Okay, not bad. And therefore you're going to get the IO. I've seen the masking, by the way, and it's kind of confusing how they calculate it, but it seems that they take a lot of steps. So add it across, you should get exactly 0.63715. Okay, so we're almost done this journey, yeah? So far so good. So this is the more convenient way to do it, I believe. Now, all we need to do now is look back into the Z table and find a value that corresponds to this. And then we should be good. That corresponds to 68715. At this stage, we're done. I believe this should be it. Let's hope I didn't mess this up. Nope, no, it's good. Okay, so let's correspond to 68715. 637, oh my god. 63715. So you just look at the probability, 63715, 637. Okay, this one looks like the closest match actually. So 6375. So this would be 0. So the Z value that corresponds to probability would be 0.35. Okay, perfect. So this means this part here must be equal to 0.35. And that's it. I think we're done. Let's wrap this up. So let's just do it here. So that means m minus 18 over 5 must equal 0.35. Therefore, now this is easy. Now you just solve for m. So times by 5 and plus 18, we should get, yep, 19.75. And I believe this is exactly what they achieved as well. Anyway, guys, I hope this helped. And let me know if you have any questions. I find this methodology a lot easier to work with. Even though it looks a bit, heavy-handed, it's all about just carefully moving things across. The very tricky part is probably the very first conditional property, because it's very misleading. Anyways, the rest of this seems okay. You just make this a subject, times it across. Use your Z values for this one, so convert this to the standard normal, like we did here. Resolve it as you always would. Throw this to the other side, and voila, we should be done. Anyway, guys, I hope you enjoyed this one, and I shall see you next time. Ciao.